you write a word problem that is about candy, and that requires the calculation of 15 divided by 3. And we'd like you to share that on this Padlet, so you can scan the QR code with your phone and then just go into the Padlet. There's a little plus bottom on the bottom right-hand side of the screen when you're in the Padlet, and then you can just type in your problem in there. And it's anonymous. Nobody's going to know. Nobody's going to know what.
And it's super easy to do that.
Yeah.
Just typing on a new little page there.
Oh yeah, Go Basanquet is Emily's at Basanquet. Emily, do you have anybody there with you? Yesterday we were at Brigden, or Tuesday we were at Brigden, and there was a few teachers in there with us.
Was there?
Yep. It's nice when groups can get together.
Yeah, it's good to have a friend to watch these with, so you can bounce ideas off of.
Yeah. She said there's a couple there.
Oh, good.
So if anybody doesn't know, there's a chat that if you go to the bottom of your screen, if you slide your pointer down there, then it should open up, right?
Yes, yeah. If you can't see it, you sort of have to glide underneath there.
And then it will say the option for chat, and then you can open up the chat. Okay, and Rod said he started recording, and it's 3:45. Wow, how did that happen?
Yeah, that was so quick.
That was really
it was
quick.
3 o'clock, like a
we
minute
can just
ago.
blabber on.
Yes.
Okay, perfect.
Okay.
So for anybody who's joining us, this is the question that we're going to be working on a little bit later in the session, and it's just going to be writing a word problem, and we're going to be looking at division, the structure of division word problems, and we're going to be looking at the ones that everybody's created on this Padlet.
Yes, so it's important if you have a sec to just do that. That would be great to have a few examples there.
Okay, so I'm going to move off this screen. Oh, look, I just click and that happens.
Okay, so welcome to our second workshop on multiplication and division. We've had session 1 last week with Tina and Denise, and so Sally and I are hosting Heather doing session 2. So we're sort of happy to be here again.
Yeah, nice to be working with Heather. She has so much to offer us, so it's always nice. I like to listen in. I listened
Picking her brain
Tuesday.
is so great. Yeah.
Tuesday was great because she points out things that we don't always pay attention to.
Oh, you know what? I didn't get a chance to get on to the Tuesday session fully.
Oh yeah.
Yeah.
It was good. It's good. And
I'll have to watch it, right? Because it's posted on the blog post. So I'm going to go back there and have a peek at that.
Okay, I'm just trying to go to the next screen. There we go. So we just want to say thank you to everybody who has joined in on the sessions. I put these 2 photos in because they're 2 of my favorites. This is the one on the left side. There is teachers from AA Right, and we happen to be working on division, so I thought it was a good image to put in. And I like how they're all smiling in the picture, and we are thinking about how to teach division. And so I think our session today is going to help everybody, and we appreciate that. You know, it's a very busy time for teachers right now. Lots of report cards are actually due today into the offices.
Yes.
So we may not have as many, but I'm sure they can listen to the recording later. But any learning you do, you know, it always, whenever one teacher does the learning in the school, it always impacts everybody because we all share what we do, and it's very helpful. So thank you for the time you're giving us. And hopefully it results in more students like this here on the right.
In turn. Yeah,
I love the color of this child's hair.
Yeah. Oh,
really
yeah. So
out.
sweet. Yeah. But that's what we want, right? Kids who are happy to share and answer, and that's what we hope that this turns into. All your hard work.
Thank you for your time.
Yeah. Thanks for being here. Okay, so we just thought we would remind you that there's just 3 more sessions coming up, 2 more on addition and subtraction, and 1 more on multiplication. So please join us for those in November.
We're just going to quickly remind you that there were some sessions prior to this one. So the very first session was with Heather, and it was Why the Continua. And it just talked about these 3 things, like how it's structured, it's how it's a valuable tool to us, and that it's research-based. And that is on the blog, the recording of that. So if you wanted to see it, you could.
And then, of course, since this is session 2 on multiplication and division, if you weren't in the first one, you might be wondering what they covered there. We should all be familiar with this image of the continuum, which we've been sort of following this year and getting to know a little bit better. So the last session, one multiplication and division, was going through the strategies listed with a key idea of unitizing, and then it had a bunch of ideas of what teachers can do to help their students progress.
Yeah, I like those 5 things a teacher can do.
Yeah.
I
Yeah.
always love a list like that. It
Yeah.
just makes my life a little bit easier.
Exactly. Yeah. And they're super practical and to use right away. So if you missed that session, that's on the the blog spot as well.
The blog pod.
The blog spot. And it's a great one to watch.
Okay. So this brings us to the start of our session. It's on multiplication division, and it's our second session on multiplication division. And we're looking at equal group problem types. Equal groups problem types.
Equal groups problem types.
Yeah.
Okay, so having said that, I guess I'm just going to introduce our host, Heather, who is always great to talk to. She's joining us from Thunder Bay. That's why we're doing these Zoom sessions so that we can have her. And she works right alongside Alex Lawson, who wrote the book. Heather has reminded me that she did her master's in the area of children development and multiplicative thinking and learning. So she's sort of a wealth of knowledge in this area.
She's spent many years focusing on this.
Yes,
that's
yes.
a mouthful. It's a mouthful to think about children's development and multiplicative thinking.
That was a lot. And she also used to train dogs.
Yeah.
On a side note, or maybe still does. Actually, I never even really thought about that.
Yeah.
You're too busy to still train dogs.
No, I still do it. It's fun.
Oh my gosh.
Anyway, we're going to move on though and talk about the mathematics today. We're going to talk about equal groups problems. Sally, can you stop your screen share so that I can share?
Sorry. Now I'm going.
No, spoiler alert. We're headed there.
It's happening again. Okay.
There we go.
Can you access it now?
We got it.
Okay.
Yeah,
Awesome.
yeah, it's all good. And I think Rod might have helped us solve one of our challenges here.
Nice.
So that's good. Okay, so I just wanted to recap some small pieces from our last multiplication and division session that are pertinent to tonight in case you missed it. So last time we looked at this diagram that Pam Harris put out on her blog that basically illustrates how she sees mathematical thinking developing over time. And we're basically taking a magnifying glass at this particular area when we look at the continuum. It basically falls of multiplication and division. The continuum of multiplication and division falls basically in this zone of the bigger picture. Last session, we looked at this problem. If I had 3 packs of gum with 4 pieces in each package, how much gum would there be altogether? And we dug into some student strategies to solve that problem. But before we did, we looked at a key idea that's really important for multiplication and division, and that's the idea of unitizing. And so what is unitizing? Unitizing is the ability for a student to be able to think about a group of objects, in this case 4 gum, and also be able to think about using their counting numbers to count a group of objects. Up until the point when a child can unitize, each number only ever represented that that specific thing. So one pack with one thing was always just one thing. And when students begin to unitize, one becomes more than one. So in this case, it's 4. And 2 now is not just 4, it's also 8, because 2 packs is also 8. And so when students begin to unitize, just that beginning step of being able to say that 4 gum is 1 pack, that is the beginning of unitizing. And so that's going to be important tonight because we're going to see the impact of the problem on students' ability to construct unitizing. And if unitizing is the building blocks for multiplicative thinking, then that is the territory that we really need to understand. How do we deepen students' key idea of unitizing, and we can actually help or hinder that based on the problems that we ask and the numbers that we have in them. Here we have another piece of vocabulary that came up the other night, and that is the idea of the composite unit. And the composite unit is defined by the word problem as what's inside the group in the case of equal groups problems. So in this case, the composite unit is that 4 pieces is 1 pack. So 4 in this is the composite unit. And I just want to remind people too that in that text chat, if you have something that you wanted to ask, a question, then that's a great spot to throw a question in there.
Yeah, we'll be watching so that we can add what people are asking.
Yeah.
Okay, so the last time in the last session, we started to look at some of these earlier area of multiplication and division strategies, and we looked at cardinality and then this idea of unitizing that we've touched on here. So today we're going to take a look at problem types, particularly division problems, so that we can better understand how to utilize them to support children's development along the continuum. And then, so one of the things, as you guys pointed out, that we talked about is 5 things that teachers, this is in our last session, that teachers can do to progress the children who are counting by ones, or the single counters, the ones who are still wanting to model out the whole multiplicative situation and count by ones. And as part of that, one of the things was to do something specific with your equal groups problems, and I showed this image. So equal groups problems have the following 3 components. They have the number of groups, they have the composite, or the amount that's inside the group, and they have the total or the subtotal. Both of them can fall in here, but certainly the total. And so for multiplication, for example, the problem that we just had with the 3 packs of gum, then the 3 packs, I'm gonna use the annotation tool here because I didn't, there we go. So the 3 packs would be the number of groups, the 4 pieces of gum, that would be the composite, and in this case, the total of that problem is where the unknown is, and it obviously is 12. Oops, I don't know what happened there. Okay, so we're going to really dig deep into looking at this structure as we look at different ways of writing equal groups problems tonight. So what is an equal groups problem? And this is a lot of writing on this slide, I appreciate. So some of you might want to snap a picture and try to make sense of it later. But basically, what's an equal groups problem? It's one where there is a many-to-one relationship that exists between the number of groups and the number of items in each group. So what does that mean? That means that in our gum problem, for example, you have 4 pieces of gum in 1 pack. That's a many-to-one relationship. 4 is 1. So that's the first bullet. The individual items in each group are discrete and can be seen and counted individually. So you could, if you had 4 packs of gum, three packs of gum with 4 pieces in each, you could actually pull out those gum and count them and look at them individually.
Mm-hmm.
And then the groups are also discrete. You've got packs, you can see those, you can count them, and they're separate entities. And so those 3 things make up your equal groups problems.
Yeah, that's a big learning thing for students, like a big idea to understand.
Mm-hmm.
Yeah, like how to actually set up those problems, you mean, once they read them.
Mm-hmm.
All right. And so we're going to move now to the Padlet. We showed this at the beginning because we are going to use some of the word problems that you've created in order to investigate some division. So we asked you to write a word problem that is about candy and that requires the calculation 15 divided by 3. So I'm going to escape now and head towards the Padlet. If you haven't had a chance to write it now, it would be a great time. And there's the QR code there. So I'll just leave that up for another second or two.
And I will say again that if the QR code is kind of covered with video faces on the side, then you can shrink that down so you can get the whole QR code.
Yeah, or click and hold and then it'll go to the top of the screen. Like
Yeah, good idea. Yeah. Mm-hmm.
And if you don't know how to use a QR code, all you have to do is if you have an iPad with a QR reader or even your phone, just open your camera and it will offer to give you the option, do you want to go to this site when it reads the QR?
Yep. It's really easy to use there.
But I know when we were setting this up, I did that with my phone. That was the first time I've ever done it with the camera by itself. It used to be you had to have a QR reader to do it, and that was pretty slick, actually.
Yeah.
All right, I'm going to move from, oh no, I have to exit. Here we go. I'm going to head over to the Padlet to see what questions we have coming in here. So if you haven't written your question yet and you would still like to, you guys sent out the code in an email too, right?
Yep, we did.
Yeah.
Yep.
So if you didn't get it on that last screen, then you can let us know in the text chat, or maybe one of you guys can put the link into the text chat in case somebody missed the QR code.
I can do that, I think.
Awesome.
Let me try.
Okay, so we've got some questions already populating in here, which is fantastic. And so let's take a look at what some of these are. So I'm going to actually put them all. I can't put them.
My phone. I got to make sure I got the right one.
Can't put them above the line. I'm going to put them all kind of in the middle, and we'll take a look and see what we've got. Okay, here's one here. I have 15 pieces of pizza before trick-or-treating, and there are 3 people in the family. How many pieces does each person get? I'm assuming we're going to share them equally because otherwise fights might break out. So I'm going to leave that one where it's sitting. I have 15 candies in my desk. I eat 3 candies at a time. How many times can I have a treat? Okay, I'm going to put that one over here.
That sounds, I like that one. Sorry, Heather.
What's that?
Like you don't like that one, or
no, I like that one.
I don't like it.
I'm
going to put this one over here.
Only 3.
Yeah, that one's for people with who are working on willpower.
Yeah.
You have 15 candies and want to give each kid 3 pieces. How many kids can you give them to? I'm going to give that one over there as well. Okay, what's this one? I want to put 3 candies on each ice cream. If I have 15 candies, how many ice creams will I be able to put candy on? Put that one there. 3 students help me clean the class at recess. I have 15 gummy candies. How many candies should each student receive?
Ooh.
So I'm going to put this one over here.
I wonder, Heather, if anybody would join in on the chat and tell us where they think it's going to go, left or right, the next one.
Okay, well, here we go.
Let's see if anybody's ready to dare and
dare to jump in on the chat. Okay, so we've got a few more left here. I don't know if there's any more coming in underneath, not yet. So I'm going to read this one. I have 15 M&Ms. I want to spread them out evenly between 3 students. How many would each student get? So if you want to jump in on the text chat, do you think this problem with the M&Ms is going to go to the left, or is it going to go with the group on the right?
Someone on the Zoom said right. No left.
I was
no
like,
right.
I don't
left.
know. Linda
Got
says
left.
A few people say, what's the who wins?
2 lefts.
Left or right?
We have
2 lefts and a
We're
right.
going for the left here.
I don't know who Zoom Tips is, but Zoom Tips says right, but then they changed their mind and said no left. 2 lefts.
All right. A few lefts. I agreed. I'm going to put it over here on the left. And so some folks are seeing a pattern in the different types of problems, whether it's going to the left or to the right. And so I wonder if you might see a pattern also. I'm giving out candies to 3 kids. I have 15 candies. How many does each kid get? Left or right?
Oh, right. We have a right. Is LKDSB and we have a left and a right.
All right. So maybe in the text chat you can make a case. Why left? Why right?
Yeah.
Takes a little bit longer.
Candies to 3 kids.
Yeah.
I have 15 candies.
Yeah.
Gosh, people are so creative with their problems.
So this is what I would do in the class. I'd be like, I have 15 candies and I've got 3 kids. How many is each person going to get? Does it match up with any on the left or the right? Maybe somebody's going to say the middle.
Yeah.
It's going to stay in the middle.
Keep it where it is.
Yeah.
We'll see if anyone comes in with an idea, and then we'll about which way it's going to go, because these two are actually, there are 3 students who want to share 15 candies. Can you make sure that, how can you make sure that they each get the same amount?
Yeah, they're match.
So those 2 are together then. How can you make sure that
same.
each get the same amount? Okay, so so they put the number 3. I just read that the 3 was the word. Students who want to share 15 candies. Okay.
So I'm actually going to move these over to the left side. And we'll take a look at these problems that we have here in front of us. So I have 15 pieces of pizza before trick-or-treating, and there are 3 people in my family. How many pieces does each person get? And there are 3 students help me clean the class at recess. I have 15 gummies. How many candies should each student receive? I guess it depends on if you want to eat any yourself on that one, because that would be how it would be in my room. I have 15 M&Ms. I want to spread them out evenly between 3 students. How many would each student get? And then these 2 that we just put over here with the candies and the 3 kids. So these are all grouped together for a reason. And then on this side we have that they want to put 3 candies on each ice cream. If they have 15 candies, how many ice creams will I be able to put the candy on? And I have 15 candies in my desk. I eat 3 candies at a time. How many times can I have a treat? And you have 15 candies and you want to give each kid 3 pieces. How many kids can you give them to? So I wonder if anyone can see a difference yet between these 2, and if not, I think we're going to go and do the next exercise and then come back to this page. Now, did you guys get the slide deck ready for me over there?
Yep.
Perfect. Awesome.
Well, the person who's eating 3 candies a day will be able to make it through the week.
That's true.
Or maybe it says at a time. Maybe it's going to be in one day.
It's so hard to tell because the numbers are the same, right? That you're kind of thinking about the numbers so much that what is different, because it is just 15 divided by 3. You know, to sort of really differentiate that is.
But the problem's different.
Okay, so we're going to jump back into the slide deck for a moment and take a look at these two problems that you guys pulled in here for me. So the first one, I have 15 M&Ms and I want to spread them out evenly between 3 students. How many would each student get? And then I have 15 candies in my desk. I eat 3 candies at a time. How many times can I have a treat? So what I want you to do is just take a moment and either using counters if you have some handy or drawings is fine. I would like for you to solve both of those problems. If you're using counters, leave the first solution up while you're doing the second one. So you have to have enough counters to do them both at the same time. I want you to use like a really early strategy that a young child might use to solve these correctly, right at the beginning before they would know, these as a fact or know something about the number family. So yeah, just using counters or tallies. How would you solve these two problems?
And actually, interesting that you say, like a young child. I actually was with someone who's in grade 5 today and talking to him about his strategies, and he showed me like he would use tiles, right? So it doesn't have to be a young child, like just someone who, like these kids are still using these strategies.
That's true. It's very true, especially as the numbers get harder. There's something in the text chat.
Oh, great point, Kate.
Thanks, Hannah. But it's surprising, right? So if you're a teacher of older students, you think that they wouldn't do this, they will. That's their go-to. They trust this one, and we've got to get them out of doing that, right? So
that's why it's hard when they get to the bigger numbers. And
once you've had a chance to try both of these out, I wonder if you might say something in the text chat to say, what's the difference here that you're seeing between these two problems when you model them out?
So Linda actually mentioned something in the text chat there. She says the questions on the right have us making groups of 3, but the questions on the left want us to share the 3 different groups. Does that make sense? Yes,
I bet you some of you mentioned the same, some of you noticed the same thing as Linda. So the questions on the left, like the M&Ms, where you have 15 M&Ms, and you want to share them equally with 3 kids. The way many students will solve that problem is to, many adults, let's say it that way, is they will take those 15, count those out, and then they will maybe fair share those out, and they'll create, as Linda said, is Linda correct?
Yes.
Yeah, that you'll end up creating 3 groups of 5. And if you ask the other problem, the problem, what was the other one that we had?
15 candies and eat 3 at a time.
Right, you had 15 candies and you ate 3 each sitting.
I think this is Pam who's doing this because somebody said Pam's can make it through the week.
Then how a student might solve it is they might, create these groups of 3 and till they get up to 15. So 3, 6, 9, 12. One of my counters is white. You guys can see it.
Yeah, you can see it.
Yeah.
Yep.
So 3, 6, 9, 12, 15, and you end up making 5 groups of 3. And this seems probably maybe pretty straightforward to us. Of course, you can have 3 groups of 5, or you can have 5 groups of 3, because the multiplication, you can do 3 times 5 or 5 times 3, and it will get you to the same place. So as adults, this seems like pretty logical. But the thing about working with kids through these types of problems is that to kids, these are completely different problems, and they solve them in completely different ways. So Linda has nailed it right on the nail head, that these two things are actually what makes these two problems different. And so in our Padlet, sorry, I'm making everybody dizzy. I forget where I'm going, but I'm going to give these a label, and I'm going to call the left side Partitive division, which is also called fair sharing, and put that up here. I think I'm done. I don't know how to make it be done. Do I just click off of it? Perfect. And I'll and I'm going to quotative or measurement. Both of these names are used interchangeably in the research, and so those are the two names of these two different types of division. So partitive or fair sharing, that's the one that typically we write.
Yes.
We, as teachers, usually when I go out to a group of, say, 40 teachers, I'll get 38 of these. And then quotative division is the one that we don't write very often, and may not even have considered some of these problems that we have over here on the right side. Might not have even crossed our minds to write one like this, because we think so much about division as fair sharing, and often not very frequently do we think about it as this measuring or doling out of an amount. So if we go back and take a look here, where we have the 3 children, this one would be partitive. And down here, where we have in this case, we have 2 numbers in the division problem, 15 and 3. And the 15 represents the total, and the 3 in partitive represents the number of parts or the number of groups. And then the unknown is, we just don't know how many is in each of the groups. In this one down here, the 15, the total still, but this time that other number in the division problem, instead of telling us how many parts, it tells us the composite unit. It tells us what's inside the group. So that 3 then becomes what's inside the group, like that. And so that's why we get these 2 completely different pictures, even though both problems are 15 divided by 3.
Having seen it on the blocks like that, you can understand how kids get confused, you know, because it is a difference there.
One of the things that's interesting is that if you ask it as a bare problem, meaning there's no word problem attached, kids will sometimes think about it in both of those ways. And oftentimes that second one, the quotative one, where the other number is what's inside the group, throws us a bit for a loop as teachers. We're expecting this top picture. And if they start to work towards this picture, we're confused, and we sometimes redirect them unintentionally. You know, we're trying to help them, but we just don't. We were expecting this, and they start making this, and it throws us a little bit.
And like as a teacher, like for the first couple of years, I feel like I only gave fair sharing questions.
Absolutely. And you know what? As you were saying that, without the words in there, it would just be 15 divided by 3.
Yeah.
Right. And so if the kid is doing that mentally, you even have a less of a picture of what
Yeah.
they're in their mind, right?
Yep.
So you don't even know which way they're thinking about that.
Mm-hmm.
So that's something else too.
Yeah, and I think where it becomes most important is how, of course, it impacts how students will think about the division. So in multiplication, going back to multiplication, we can have, 3 groups and the 5 inside each group. That matches our first drawing that we had, or the top of the page when we were looking at it. And then in multiplication, of course, the total is what we don't know. Or we can have 5 groups and 3 in each group, and the total be unknown. We can ask both of these problems, and we feel very comfortable, I find, when I work with teachers, flipping back and forth and saying, oh yeah, these are the same thing. These are going to give you the same amount. We maybe haven't totally considered the 2 different pictures that we have over here. But, we can certainly produce both those pictures and feel quite confident that those 2 amounts are going to be the same. But with division, we feel way less comfortable with switching things up. So let's take a look at this with division. So division, we have the total.
Oh, I'm thinking M&Ms. This was the M&Ms question, no?
Yeah, that's right. The M&Ms question. So we had the total, and then that second number that's given is the number of groups. How many groups are there, or kids, or bags, or something like that. And that the part that we are looking for is the amount inside the group. That's where the unknown lies in partitive division. In multiplication, the unknown is up here in the totals, but in partitive division, the unknown is in this spot here. Now with quotative division, of course, we know the total, but this time the second number that's given falls into this spot here. And then the unknown is how many groups there are. And this last image, this last part, is the one that we don't utilize to its full potential in classrooms. And not only that, it's actually extremely important for a variety of reasons. So I think what we're going to do is I'm going to just switch things up because I'm looking at the time, and I want to make sure we get to some of the juicier bits later about why this matters. So I want to make sure we don't spend too much time here. So I'm just going to switch up around because some of the videos are sweet, but they're a little bit long, and I think we can make a little bit shorter time if we skip those. So we're gonna go, and I'm gonna show you a word problem here. And so I have 24 eggs in the fridge for baking cookies. If each recipe requires 4 eggs, how many recipes can I make? And I want you to just quickly, with your annotation tools, if you wouldn't mind, just try out, like, do you think it's partitive or is it quotative? What do you think, this problem?
I've got to reread the question. I have 24 eggs in the fridge.
Someone has answered here. Quotative.
Oh, fast.
Yeah. I'm also going to answer.
I got to find annotate. Oh, it's under view options at the top. And then you can click a stamp.
Right. If you're on an iPad, you don't get that stamp option. So you have to use sort of pen. There's an icon that has a pen on it. I also think I'm going with that one.
Somebody use a question mark.
I like that one a lot.
But not really sure.
Not being sure is a good place to be because this is probably, I know for me when I first learned it, it was certainly new information and I didn't really know. So let's take a look at it. The total is given, 24 eggs in the fridge. So that puts us in the division realm. So that's a good spot. So it's division of some kind. I didn't even ask you if it was multiplication, so that maybe gave it away. But the next number, is the next number the composite or what's inside the group, or is the next number tell you how many groups there are? And that's really how I think about partitive quotative. So if this number, this second number, tells you what's inside the group, then that makes it a quotative problem, which is what everybody has said. If you weren't sure and you weren't brave enough to put your stamp in the wrong spot, don't worry. We'll, this is the kind of thing that I hope generates some conversation around this. There's the text. Okay. So students will, when they're solving a quotative problem, will generally use one of these two strategies, counting all, and then grouping by the composite, which is what I showed you earlier with the 15 divided by 3. Actually, I don't think that's what I did. Actually, I think I did the modeling composite units and then counting by ones, and if division, recounting, because I built up as we went there, just to speed things along. But often in the beginning, those are the two strategies you'll see for division. Counting all and grouping by the composite, what they do for that one is they count out the total, the 15, and then they pull out the groups of 3 until they run out of counters. And that's the reason why that's on the continuum way far over on the left is because that's something you see with very young, grade 1s and kindergarten students using that type of strategy. Here's another problem to try. We bought 42 feathers for a craft. If 6 children are making crafts and we want each child to have the same number of feathers, how many feathers can each child have? Is that partitive or quotative?
Ooh, I feel like this is tricky. It's 6.
Oh, people are responding fast.
You guys are so
I'm going
quick.
to copy them.
Progress. It's 6 children. Okay. I feel like partitive is the share, right? So we're sharing out.
Yeah, that fair sharing.
Yes.
So that's exactly what you guys are definitely picking this up much more quickly than many folks. So knowing that second number, that's telling me how many children. So that's the groups, and I just don't know how many feathers each of those children is going to get. So oftentimes when students are working through this type of problem, they will, what's interesting is they actually struggle with partitive division, and we're going to get into that in a moment. Partitive division is harder for young children, so they will often think about those 3 groups. Can't even remember the question we were looking at. It's actually 6 groups, right? Because we had 6 children.
6 groups, yeah.
I'm going to change my piece of paper because it'll just be confusing, I think. So, they will have 6 groups, and this is a bigger problem. So this is for older kids, but they'll be thinking about like, how many am I going to put in there? And they won't know. They don't dole out one at a time the way that we might think that they would. Often they will just try something. They might just say, well, I'm going to try putting 5 in there, and then see where that gets them, 5, 10, 15, 20, 25, 30, and then try to figure out how they're going to get up to 42. So they might add 1 at a time after that. So they might go 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, something like that. And then they would know that everybody was going to get 7. And so often, and I didn't put it in the slide here, but actually what you often get is this trial and error happening with Partitive. Especially
like maybe they start with 10, say 10 in each one, and then like too much. So that's the error, and then they try something new.
Yeah. They're gonna work up to it. But it's interesting because what they actually want to do is they want to actually work with the composite, but they don't know it. So then they have to try something out. Okay, so 5 benefits to understanding and asking both types of quotative division problems. So here we go for the race for the finish here. All right, number 1, I already said this. Children find quotative division problems easier to solve than partitive division problems. Because of that composite is so defined, and then they can work with that composite instead of guessing at what it might be, it does make it easier for them. Now, older students who've never solved quotative, that does not hold true for them. If they've only ever solved partitive division, they are thrown for a little bit of a loop when they hit quotative division because they've never experienced it before. But if young children, when they're first when you're first working with multiplication and division, if you use quotative division, that they will find that easier than partitive division, which is surprising to us because we think about division in a fair sharing way. So that's usually a bit of a surprise. Quotative questions, here's reason number 2. Quotative questions help students to make connections between multiplication and division. Because they're working with that composite, it allows them to repeat that composite over and over and over again and build up to solve division. And so that building up with the composite looks identical to multiplication questions. And because of that, they can make use of and make connections to multiplication when they're working in division. And that is a powerful and important connection for students to make.
I was thinking on the your last sheet there, Heather, it looked like a decomposing the factor when you're doing 5, 5, 5, and then you had 2 tallies kind of thing.
Yeah, it does help out. So I was thinking about that connection too, although that's partitive, and I was thinking about how partitive could help with that. But that's a whole other conversation, Sally.
Okay, sorry, sidetracked.
That's okay. No,
and you have good. 1 minute left.
Yeah, not even. I think I'm already over time. Number 3, quotative questions set up the students to better understand the alternative algorithm for division. And I thought we would have time to dig into an example of that. But basically, when we're thinking about the algorithms for division, I'm just going to set it up and you guys can play around with this. But I was thinking about a question like you're baking cookies for a craft fair and you want to make 104 cookies, or you do make, and you're going to put them in bags with 4 in each bag. So how many bags can I make? And so with quotative division, we're thinking about how many bags of 4 can I make from 104 cookies? And you're pulling out bags with 4 in each bag. And thinking about division that way as opposed to goes into or whatever, I think is more helpful for students to really understand how to work with that, with your division algorithms. I don't know if people are going to feel badly that I didn't show the whole algorithm there, but
well, they can always
afterwards
coach,
we'll
right?
go back.
Yeah, because you showed us that.
Yeah. And then, so that was the question that I put out.
You can always tune into the next session.
Yeah, well, hopefully we can get into the alternative algorithms.
Mm-hmm.
So number 4, quotative questions are absolutely necessary to understand division with fractions and decimals, which may seem like a long way away, but it is in the grade 6 curriculum to be able to divide by 10th. And so, and in order to be able to do that, we have to do the other fractions first in order for kids to really understand it. So here's an example. We've got a half. How many half cups of rice would fit into the 2.5 cup measure? You know, how many scoops would I need? So there's a quotative example that's absolutely necessary for our kids to understand division with fractions.
Yeah, that's a good one.
There's just a problem for folks who wanted another version of that. So you're volunteering at an animal rescue shelter and a patron donates 3 bags of special puppy food. If the shelter uses 1/3 of a bag of food each day, how long will the donated food last? And number 5, working both partitive and quotative division problems helps students better understand the relationship between the two. And that relationship underpins the commutative property, which will really help them out in the long run as they develop multiplicative thinking, really knowing how those 2 different types of multiplication, those 2 different forms of multiplication are related and how you can move between the 2. So those are the five reasons why I think it's absolutely critical that teachers of all ages and from K to 12 really understand the difference between partitive and quotative division. And I think that's all I have.
Well, thanks, Heather.
Yeah,
that was really good.
That was really good. I always learn so much.
Mm-hmm.
I think this slide is just showing some resources you can go to learn a bit more.
Yeah, they have examples of those types of questions in the Division 1, Volume 4. And it's really interesting the 3 parts, right? Like how it could be the composite or it could be the group or the total. It really makes you think about, though, like when you think about it in that way, you see it all the time.
Yes, it's very true. Yep. And it's interesting too, because if we're more knowledgeable about that, then we can see the way that our students work when they're
how to help them.
Yeah. I'm not sure what's on the next
I think
slide.
we have another slide there, Heather, just real quick. Oh yeah, so don't forget, you can ask a colleague, connect with a coach, go to the blog for some more ideas. And then the What to Look For book, of course, and it has that whole section on that, what Heather talked about, and then our guides to effective. And attend another session, which the next
the next slide has the sessions on it.
Next week.
Yep, next week, Tuesday and Thursday. And then the following Tuesday.
Yeah, so hopefully you can join us. And if you have a moment, if you could give us some feedback on the session, there's the QR code.
So thanks a lot. Expert QR code readers today.
Yep, there's the QR code again there at the bottom.
Thanks so much, everyone, for joining us.
Thanks
a lot, Heather.
And thanks, Rod, for the background help today.
Thank you very much for you guys for being here and taking the time out. I really appreciate. For me, I think this is really important information. So thanks for that.